So you should be able to do these guys. It's a class opener, technically, for these set of notes. So like, for example, number 1, we have 2 plus 1 on top over 6 plus 4 on the bottom. You do the 2 plus 1 on top and you get what?
3.
And on the bottom? Could you reduce? No. Okay, so go ahead and do the rest. That's the answer, 3/10 for number 1. Go ahead and do the rest. So here are the answers. Number 2, the answer is negative 2/5. And then number 3, we get 8 over negative 6. But we could reduce that one. Let's reduce by 2. And if you divide 8 by 2, you're going to get a 4 on top. If you divide 6 by 2, you're going to get a 3 on the bottom. And that negative sign that's on the denominator, it's better if we put it out here in the middle, or you could put it up on top. But never leave a negative on the denominator. Anyhow, that is your answer, or your answers for the class opener. Let's move on to the actual notes for today. Slope, aka rate of change. Okay, so what is slope? When you guys hear the word slope, what do you think of? Anything. It doesn't have to be math class.
A crooked line.
A crooked line, okay. Anybody else? A mountain, that's right. Okay, so yeah, we got the right idea. Slope is, it's really the steepness, right? The steepness of something. So maybe the steepness of a mountain, the steepness of a ramp, whatever. So slope is the steepness of a line. It tells you the direction your line is going. You describe your slope with the fraction. Okay, so this is something that we need to really learn. This is very, very important. A slope is really a fraction, okay? And the top number is the rise and the bottom number is the run. So the rise is positive if from left to right the line's going up, okay? The rise, if the rise is negative from left to right, it's going down, okay? So the run is always positive. Slope is always represented with the variable m. I don't know, maybe because m for mountain? I don't know, whatever. I really don't know why it's represented with the variable m, but m always represents slope, okay? So once again, your slope, so if you see m, that really means the word slope. Your slope is going to be a fraction, rise over run. Now, the number on top, the reason why I have this plus minus, as a matter of fact, it's probably a good idea to do this. Put the plus minus in a little cloud because it doesn't really mean plus or minus. It's really saying what I wanted to say right here with this little plus minus is you could have a positive number up on top or you could have a negative number up on top. If it is positive, then you're going to be going up. If it's negative, then you're going to be going down, okay? But the run, for the sake of making this easy to understand, we're going to say the run is always positive. We're always going to look at lines from left to right. Okay, so the rise could be going up or it could be going down. If it's going up, it's positive. If it's going down, it's negative. But the run, we're always going to look at run from left to right, so we're always going to look at it positive on the run. And the formula, which we're going to have to memorize later on, and what I mean by later on is in a couple of minutes, y2 minus y1 over x2 minus x1. You see, the rise is really going to be the difference of your y values. It's like if somebody's 6'2" and somebody's 6'5", and I say, what's the change in their heights? What's the difference in their heights? 6'2" to 6'5". 3, right? 3 inches. That's the rise, right? That's the change in the height. So, and that is subtracting their heights. The 6'5" take away 6'2". That's how you get the 6'3". So the rise, you're going to find it by taking one altitude and subtracting the other altitude from it. The run, same thing. You're going to take one x value and subtract the other x value from it. And we are naming them y2, y sub 2 minus y sub 1, x sub 2 minus x sub 1. And that is the formula for slope that we're going to have to learn in a little bit. But right now, let's really understand what slope is before we start working out the formula and calculating slope values. So let's all go to this first blank xy plane. Now let's put a coordinate let's put a dot at 0, 0 at the origin, okay? And let's put another dot at the coordinate 1, 4. Now, this line right here has a slope, okay? What is that slope? Well, remember, slope is rise over run, and we always look at lines from left to right. So from here to here, does it rise or does it go down? Does it rise positive or negative? positive, right? You look at one dot here, the other dot over here. So when you compare these two dots from left to right, from here to here, it's going up. And how much is it going up? 4. How much is it going over? 1. So the rise is 4. The rise is 4. The run is 1. Okay? Let's try a different one. Let's go to the coordinate -2, -4. -2, -4 is right here. And let's go to the coordinate 1, -3. Right there. And let's draw a line right through it. So what's the slope of this line right here? You look at one point, you look at the other point, and you ask yourself, do I rise from left to right? Am I rising, or am I doing a negative rise, which means dropping? You're rising. So from here to here, here's a question. From here to here, am I going up or am I going down? I'm going up, right? So that's going to be a positive rise. So when I look at my slope up here, when I think about my fraction, it's a positive rise. Now, how much does it actually rise from here to here? It only goes up 1 level, right? 1 level. How much do I run? 3. So my slope right there, ladies and gentlemen, my slope is rise 1 over run 3. So my slope is 1/3. Are you with me? Okay. Let's do a couple more. Let's go for one over here. Let's go to the coordinate -4, +4. Go to the coordinate -4, +4. Put a dot right there. And let's go to the coordinate -1, +2. -1, +2. And let's draw a line right through there. So from left to right, again, we always look at lines from left to right. Kind of like if you're reading a sentence, you go from left to right. Same thing with lines. Pick 2 points. You have 1 point here, 1 point there. From left to right, am I going up or am I going down? Going down. So my rise, ladies and gentlemen, my rise is going to be negative, right? It's positive to go up to heaven, negative to go down to hell, right? Okay. So from here to here, you're going down how much? 2 levels, right? So the rise is -2. The run is how much? 3. And the run is always positive, okay? So from here to here, I'm going down 2 levels and over 3. So my slope is down 2 over 3, -2/3. You get it? And it doesn't matter if your lines are located in the first quadrant, the second quadrant, the third, or the fourth. It doesn't matter where it's at. Wherever your line is at, pick 2 points. And I'm giving you the 2 points here. You pick 2 points and you could calculate how much you're rising, how much you're running. Okay, let's do one more. How about, okay, that one's ugly, but you get the idea. We have a coordinate at -3, -1, and we have a coordinate at 4, -2. From this point to that point, from left to right, am I going up or am I going down? Down. How many units do I go down? 1. And how many units do I go over? 7. So what's my slope? -1 over 7. That's my slope. So I think we're starting to get a hang of the slope situation. And we always look at lines from left to right, okay? And we have positive slopes, we have negative slopes. And again, it doesn't matter if the line is up here or down here. If from left to right it's going down, this one has a -2 slope. -2 is the rise over 1, 2, 3. So this is a slope -2/3. This one right here, it's going up 1, so it's a positive slope. So as long as it's going from left to right up, then that means it's positive. From left to right down, that means it's negative. Okay, so you got to know that. What if your line is going completely just left and right, totally flat, not going up, not going down, just totally flat? What kind of slope do you have? What's the steepness? 0, right? If I tell you how steep is the floor, it's not steep at all, it's 0. So the slope is 0, okay? Now, if your line is perfectly going straight up and down, then that's what we call an undefined slope, okay? Because it's so steep, it's undefined. Let's see if we really understand this. So here's a situation. You're a motorcycle stunt driver, and you're about to perform the most dangerous stunt yet. you want to jump several school buses, and your stunt team is going to build your ramp. So they ask you, what slope do you prefer on your ramp? Do you prefer 70 over 11 or 11 over 70? Okay, again, the options are 70 over 11 or 11 over 70. What do you say? I want to pause it here, give you guys some time to discuss it, and we'll continue with what the correct answer is. So I had this drawn on a piece of paper. Hopefully you guys enjoy it. So here's our first option, 11 over 70. So you are a motorcycle stunt driver. There you are. Yes. Let me place you right here on the street. Let me move this over. Make it a little bigger. Why not? Here we go. So the slope, 11 over 70. You turn on your motorcycle and you're nervous because you're going to jump several buses. 11 over 70. Let's see if this slope works. And there you're off, and you're going faster and faster and faster. Then all of a sudden, here comes a ramp, 11 over 70, rise 11, run 70, and you jump over those buses. Yes, you're flying, and you land perfectly, and you're successful, and you're the best stuntman in the world. Let's try option B. What if you said 70 over 11? You say 70 over 11. Here we go. We turn on our motorcycle, and you're nervous because you don't know if this is a good slope or not, but here we go. You turn it on. You're going as fast as you could, going super fast, then smack. You're dead. Yes, that's right. Look at him. Look at you. You have no leg. It's bleeding. And your final thoughts as you drift from this life to the next is, dang, I should have paid attention in algebra so I could understand rise over run, slope. Anyways, let's analyze this. Of course, rise 70 over run 11, that's going to be like smacking right into a wall. Ridiculous, right? The appropriate slope to jump the buses is rise 11, right? Rise 11 over run 70, right? So that's a nice jump. The other one, as you could see, results in death. So on this one, let's say we all go skiing for the first. I've never gone skiing, all right? Let's say we all go skiing for the first time. And they ask us what we prefer to ski on our very first attempt, the slope -4 over 99 or -99 over 4. Huh?
How can you have negative?
Now remember, negative slope, it's just going down. Yeah. The negative means it's going down 4, right? So you don't want to ski up a mountain, you want to ski down a mountain, right? So that's when you have negative slope. Good question. But anyway, talk to a partner and see what you decide, whether you prefer to ski down for the first time, if you've never skied before, -4 over 99 or -99 over 4. So yeah, if you picked -4 over 99, that means that the rise -4, you're going down only 4 feet as you run 99 feet. So if we all did this for our very first time, it would be nice. You just skied down this nice little slope. You're happy. But let's say you chose -99 over 4.
Oh my God.
Oh my God is exactly right. -99, you're going to drop 99 feet. Oh, with only a 4-foot run. I mean, seriously, this guy up here is not going to, you're going to just die, right? Okay, so that's my little lesson for slope. Hopefully you guys understand it a little better. And now to go back to the notes, we do have our slope formula because obviously we're not always going to see visuals like that. Sometimes they're going to give us just 2 points on an XY plane, and we need to calculate the steepness of the line, the slope of the line. Now it's pretty easy if you see it visually, like right here, this positive slope. From here to here, it goes up 1 over 2, so the slope is 1/2, piece of cake. But what if they didn't give you the actual visual? They didn't show you the line. They just gave you some coordinates. We're going to be able to use this formula to calculate the slope. So for the sake of time, we're going to end this video here, and we're going to pick up the next video where we actually apply the slope formula to find the slope when they give us 2 points without actually seeing it on a graph.